Yes. So, welcome everyone. This is the afternoon session of day one of LaTeX workshop. So, before in the pre-noon session, we have seen the very basics of the LaTeX in the overleaf editor. In that, we have seen introduction, text formatting, some maths formulas, and packages and environment. So there was some problem using hyperref that the equation referencing were not. Uh, there was an error for the referencing, but then I have copied the same content and made a new file because named it with a different name with the same code. Now the referencing works. I mean, I don't know, sometimes the editor will give you crazy errors, or maybe there must be something wrong in some in between codes. So I had removed some begin, center, begin, huge, those kind of environments. I have removed and put in this new page. So now everything works. For example, so you see I have a begin equation here. So where is this? Okay, let me reload. Yeah. So this is a feature of overleaf that suppose you are in the PDF and you want to locate the code of some file, some text. Okay. For example, this equation number one, e raised to I pi plus one. I want to locate the code of this equation. So you just go here and do the double click. You will directly go to this equation. See, begin equation and equation. This is a really cool feature of this overleaf editor. So now before the labeling was a problem, right? But now then I removed some in between bunch of code, and then everything is same. You use the hyperref package exactly, nothing else. And now if you label it, so this equation e raised to I pi plus 1 equals to 0, I have labeled as Euler, so E should be capital. And then when I refer it in just the next line, as you see, equation slash EQREF, which means that this is an equation and you are referring by the label Euler, is called Euler's equation. So here you can see a nice reference scheme equation and with the hyperlink, so that if you click on this link, at the top of the page you will see equation number one. Right? Now this works fine. Hyperlinks. So now you can use hyperlinks in very different ways. For example, here I have used. So basically this is the new text file that I have created. So anyone with this link, so how I made this, anyone with this is a text, then I use the command href with the two brackets as before. In the first bracket, I have pasted this link to view this file. And then in the second bracket, I entered the text that I want to, attach the link to. So this is link can view the project. So if you click on this link here, you will go to this project again in a viewing mode. Okay. So just this link anyway, I will copy and paste in the comment section of your meeting so that you can directly go and see the PDF that I'm compiling. Okay. You can, so I'll pin this message. Yeah. So you can directly go in this link and then see the whole project. Okay. The overlay project directly, what I'm writing and what the PDF is compiling. So let's go to the projects. Okay. So this was about using images and hyperlinks. So now let's start a new subsection basically, which is tables and graphs. Okay. So here I'll tell you how to make tables with some nice colorings and all. Okay. So very basic syntax for table is begin tabular. Okay. So as soon as you enter begin tabular, it will give a default format for it. So you can see after begin format, begin tabular, there is one squiggly bracket inside. There is C with a vertical line C, and you see what it will output, just a vertical line, right? Because there is no content in the table as of now. If suppose I'll put something, this is table. So let's recompile. Yeah, so see there is a table now, but it is so you have, this is a very basic table which doesn't have any kind of specifications. I mean, it is just kind of divided into two parts, just a small table. So now you can do so much with this table. For example, now what we'll dive into the notations. What does the C stands for? So the C means the first in the first column, the text will be centered. Okay. So if you write so much of stuff, you can see the text, this, right, this A and E's table, these are all centered and then it will go in both the directions, right? If you want to make the text left aligned, let's say in the first column, then I'll put /L. And maybe let's say the second column is I want to make the text right aligned. So I'll put R there. Now as you can see, everything in the first column is aligned to left, everything in the second column is aligned to right. Okay, so these are the some alignments. What else you can do? In a table, you should expect boundaries, right, everywhere, right, top, bottom, and sides. So you just have to tell in the tabular, first vertical line I put there before L. So now you can see that it came, a line came at the left side of the table. Then after R, if I make a same vertical line, then there will be a line again. Yes. So now this is, we have 3 lines. We want so many lines, but at least one top line and one bottom line. Right? So how do we make this? After begin tabular, before the content, no, this is a table. Before this content, you want a horizontal line, right? So what you tell the compiler is make h line. So h lines means horizontal line. So /h line will give you a horizontal line above. Yes, and then at the end you put /h line. It will give you a horizontal line below. I think there will be a problem here, but let's see. Yes. So a problem because now the compiler cannot distinguish between the cell entry and the command h line, right? Whatever comes this after this ampersand is kind of treated as a cell entry, right? The A22 entry in the matrix sense. But you don't want h line to be an entry, right? So what you will do is you put a double slash to tell the compiler that okay, the matrix is now ended. Then you have a h line. Then you get an h line at the bottom, right? Also now if you want the horizontal line in the middle, you just go after the first line, put again an h line, and done. This will give you an h line. Okay, so this is a very basic table. This is a table. Now we can see what problems we can run into. Let's begin tabular. Again the same, let's make it okay centered, keep it centered, C. But this time, okay, let me write something. MSc Mathematics. I don't know. Some scientific computing. Then this row applied mathematics. Right. Okay, first of all, this doesn't look good because after the first table, the second table is coming directly. If you want, we can just add a new line so that it will come down. So that. Yeah, it came down, but there is still no much gap. So what you can do is you can do /v space. It will give you some vertical space, and inside squiggly bracket you should mention how much space you want. So like there are units here. You can use centimeters, millimeters, or also this points. There is a unit called point. So it's like the point, the letter space. So v space 10 points. I gave a 10-point space after the first table, bit before the second table. Okay, now I think the gap is not enough. Let's give 1 centimeter. Okay. Let's make H line. Now there is a line, right? There is a too much gap. Okay, and now in this cell, I'll write a very long content. Okay, let's say this is, I don't know, cell, some random stuff. So let's see what happens. Still it is showing because we already have stretched the boundaries. But suppose this is, I mean, very big paragraph, like yes. So now you see there's a problem. It will just keep going. It will just keep going. It doesn't know when to, shift it to the new line. Right? For that, you have to specify the column width. What should be a column width? Okay. So for that reason, in the second column, let's say I write, instead of C, I write M. In the squiggly bracket, I write, let's say, 4 centimeters. So now 4 centimeter is the column width of my second column. Okay. Right. Now you can see everything is nicely aligned in the second column with the column width of 4 centimeter. Right? And why do I wrote M? M means that the things which are in the other column will be in the center. Okay. Otherwise, if you write, let's say I can write, I don't know, M, L. No, I think L is not good. Yeah, L doesn't work here because you are in squiggly bracket. Either it is middle, bottom, or the top. Something like B if I write. Yeah. So basically, this is just you have to remember the syntaxes. Yes. So what I did is I put B 4 centimeter. That means everything in the other column will start from the bottom. Okay, but this is not considered a good writing style. So I put again M 4 centimeter. Yeah. So this is a big table, and you can now set the column width accordingly, and the text will automatically get aligned. Okay. Okay. So now we know how to make borders. Now there are certain specifications. Now, I mean, for the artistic purposes, you may want thick borders, or you want to color some parts and all. So I'll include some special code. So for instance, this code, okay, set length of table column separation 18 points. Okay, you can now I comment it. What this will do is, by the name it should be clear, set length of table column separation to be 18 points, right? So as you can see here in table, the text start very early, right? There's some problem with connection. Yeah. Yeah, as you can see, the text will start very early after the borders. But if you want to increase the column space, you should apply this set length table column separation 18 points. Now the text will start after 18 points gap, and also from the top and from the bottom, right? For top and bottom, you have to use these two commands. No, just one command, right? So this command /renew command array stretch of 1.5 centimeter. This command by name is not clear why is it called array stretch, but basically what it will do is the white spaces in between the top and the bottom of every text, it will stretch it by 1.5 times. Okay. So now if you recompile, you see a kind of spacious column. Yeah. So from the sides, it is 18 points gap is there between the border and the text. Also from the top and bottom, the gap is increased by 1.5 stretch. Okay. The next thing is, if you want to kind of a border, you want to border it with some thick borders, then you use this command, set length of array rule width of 0.5 mm, right? So now you can see the borders are thick. So you can set these different parameters, 0.5, you can set 0.2, 0.3, anything. And this by name it is very clear. This set length is a command which allows you to change the parameters. And then what parameter you want to change? You want to change array rule width by 0.5 millimeters. So let me recompile. Yes. Okay. So let me go here. Yeah. So next thing you want to do with the table is you sometimes want 2 or 3 rows to be combined in just one row, and the rest everything will be separate rows, right? For example, you want something like let's say what example we can take. Okay, let's create /begin tabular. Okay. C. I'll make another column C. Something like marks of MSc Scientific Computing, MSc okay, this doesn't make any sense. Okay, I'll just add the random column. I want 3 column, let's say number just 1, 2, 3, and then 4, 5, 6, then 7, 8, 9. Okay, this created a table, but no, I want it below this table. /v space 10 point. Okay. Yeah, I want h rule, h line. Here also I want h line, h line, h line. Okay, here the 2 signs are missing. Right, yeah, at the end, okay, yeah, here it is missing. So what I want is the 4 and 7, these two numbers, like as a matrix, if you consider A22 and A21 and A31 entries, I want those 2 entries to be clubbed together. Okay, so how I will do it? So for this I need the package what is called multi-column. So let's go at the top and I use package. Yeah, so the package is already included. I have included multi-row, and multi-row is the package which will allow you to make multiple columns or multiple rows, And array is, you should use the array package all the time whenever you play with tables. Okay, so these are the two packages useful for tables. Okay, so I should label everything here. Used for hyperlinks. It should be clear by the name. This is not included. Yeah. Okay. Yes. So now what I want to do is, at the place of 4 and 7, I want to put a multi-row, right? So see, as soon as I typed mult, it will give me the things multi-row, right? So how many rows you want to make multi-rows? 2. And what should be the spacing? Let's say 2 centimeter. And what do you want to write? Let's say I'll just write multiple row. And now, because this row, this entry A21 and A31 are now considered as a multiple row, I have to remove this 7th entry. Right? Yeah, also this H line. Yeah. Now, let's see, the second and third row are now combined in kind of one row, right? And then, yeah. So this is the use of multi-row. Similarly, you can do multiple columns. Like for example, if I want one single column at the very top, add some title. So what I'll do is I'll make multi-column, and how many columns you want? 3 column, and type also I want again here something C, here something. So like these are 2 borders and 1 text. Right? So and then I want to write multiple column. So let's see, something trouble. Yeah. Okay, I should make this. Okay, so here you can see a nice multiple column named column has appeared. The only thing is I have missed one H line again. H line. Yes, perfect. Right. So now there is now you can use this kind of format for any classifications, right? Now for marks of some classes or any example. I can't think of an example right now, but you understand, right? What will be the use of this? Okay. Okay. Any doubts as of now? Okay. So what else you can change? These borders, sometimes you don't want black borders and all to make the you want to highlight something. So there's a command called array rule color, and in the squiggly bracket you write whatever color you want. For example, I want blue, right? So I just wrote there blue. Let's see what it make. Yeah. So now you can see the column, the whole borders now became blue colored. Right now you can change whatever color you want: blue, red, yellow. And for this reason, first of all, directly it won't work. It should include this package, coloring borders in tables, etc. Okay, this is not just for coloring borders in table. It will include color package. The table I have included here only because it should understand. It will behave nicely with table. So these are optional parameter table I put. Okay, with the color X color package, I can now color every border. So next thing is there are three types of three types of columns that we have seen as of now, right? L, C, and R, right? But are they these are the only ones, or you can make your own, right? So the answer is yes. You can make your own type of, let's say, column. So you have to go to again preamble and okay, where did I made somewhere new column type? Yes. So here. So now you can see this is the command. I will uncomment it. Yes. So this is a command to make a new column. I'm defining a new type of column. So of course the command is slash new column type. In the first bracket, I have to mention what the name of the column is. The name is S. And then in the next squiggly bracket, I have assigning. This symbol is for assigning. I'm assigning this column as color, column color. So the whole column will be colored blue. But not just blue, as you can see here, there is another command called exclamation sign and then 30. What does this mean? So if I do full blue, nothing will be visible, right? Then it will be darker blue, whatever you wrote, nothing is visible. So this percentage sign will tell how much blue you want. No? So I want only 30% blue, remaining will be white. And then kind of, the color will be, the opacity will be more. You can see the text there. Okay. This is the color I have assigned, and then the type. I mean, this is a new column type, but of course it can borrow the properties of the previous ones. So the text will be centered here. For that, I use the C command here. Okay. So this is the description of a new column type. Now I will use this column. Okay. So let's go. Basically, I can double click on some PDF. On some text in the right hand side, and then it will redirect me to the code location. Let's make a new table now. Begin tabular. So in place of C, okay, I will make, let's say, first column C and second column S. Now, as you can see, the second column is ready-madely all blue. H line. So again, this is new table. Something like this. So slash H line, then slash H line. Yeah. So the complete table is ready. This is a new table, and now you can see the second column is completely in the blue color. You can give any color and it will be of that color. Okay. So if you want to change the border, let's say, I'll make a new command here, because earlier I have defined this array rule color blue. So everything with what follows will have blue colored borders. But now I will define here again array rule color. Array rule color, let's say red. I'm defining red. So now the borders will be red and the rest everything will be same, right? So this defining I can do it any time in the code, and I can also define it in the preamble so that everything will be of the same type. But yeah, this is more convenient. Okay. So this is a very basic prototype of table. Tabular basically, but Overleaf has something more for us. They have already created one nice environment for these tables, which is table. So begin table, end table is an environment, right? So here, as you can see, everything is nicely set up. They have created centering. So the centering means everything in the environment will be in the centered. So basically, this is a kind of a shortcut for a begin center environment. Okay. Right. You can see some weirdness here in the right hand side. Now we'll get back. We'll get to that later. So what table? Let's say I'll copy the same table here. Begin tabular CS. Okay. Paste. Yeah. So you can see this table one caption came, popped up at the top We don't want it there, first of all. So in the table, in this square brackets, you can put h. So this h command means here, right here in the code where where the code is, you put the output there. So the code was after this table, hence just a minute. Yeah, hence the new table will come after that, right? And it is centered. So this is how this first bracket works. And then now you can see this is the tabular environment as before. Then there is something called caption. You can caption your table whatever you want. Let's say I'll just call my table, or let's say new table. This is my new table, and I can label also. So label also, let's say I'll make new table. So why this labeling will require is, so as before, you can refer it back. Okay, I'll just write /ref. See, tab new table is a good table. Okay, so now what happens is if I recompile, yeah, so here it gave the reference along with an hyperlink. So if I click on this, I'll get to table 1, new table. Some weirdness, it shows it at the very top, and because of the laptop sizing issue, it just goes very top. So you have to go up. Yeah, so this is a very nice table environment which has all things that you need to show a nice kind of a table. Okay, so this is all about tables. So whatever I am telling about different environments, that will be just scratching the surfaces. So you can go and go in overleaf or go and search for the manuals, and you can go in much depth in all of these commands, all of these environments, because overleaf, basically LaTeX, has the advantage that you can completely command him whatever you want, right? So it's kind of advantage also, disadvantage also, but fine. I mean, it depends. So please go again in the overleaf manual and all, and look this information in depth. Okay, so this is about tables. Do you have any questions about tables? Even for this, yes? Yes, any questions? Yeah, so even for these images, instead of directly putting image, there is environment called figure. So you put it in the figure environment. Let's say I remove this and now it's a very nice environment, centered environment. There is a caption. You can put caption to my figure. What for Raycon it is. And then I can label as fig for Raycon. Okay, let's see how it comes up. See, this is the problem now. Why the image is not showing up, right? You might feel okay, some error is there, but there is no error showing, right? I mean, this is a warning, this is not error. So what happens with this image is a very big image, right? And you haven't scaled it yet. So what you should do is you should scale it. Scale equal to, let's say, 0.1. So that means the image is now scaled to the 1%. So now you can see, yeah, so this is my image. Okay, again, the image was not here between these matrices. There is no matrix thing here. The matrices are where? Long before, I guess. Yeah. Again, they did some weirdness. So you have to tell the compiler that, okay, it should be here, /h. So here, include images, hyperlink. So now here, it will show my this Fourier cone figure with the caption, figure 1, Fourier cone. You can refer it back also. So I can write it here, figure slash ref fig 4 ray cone represents the 4 ray cone in slash R3. The slash R I have already defined, I suppose. As no, I haven't defined, I guess. Yeah. Everything else is fine. Only problem is R. Okay, so I will define a command slash declare math operator. No, in fact, yeah, just slash new command. Slash new command slash R. And what it will do is it will give me slash math BB of R. Yes, perfect. So here it will show figure 1 represents the Fourier cone in R3. That's all. This is link, yeah, these are two links. No, yeah, so this figure 1, hyperlinks are now working perfectly fine. Yes, this is figure 1. Yeah, now let's go away from tables and let's make new, not section. We already had a section, right? So another feature of this overleaf is you go into this tab, and in the file outline, it will show you different kinds of sections, right? So this that introduction is the main section, I suppose, and then these are subsections, text formatting, tables, and all those things. So I think I should have made another section for tables and graphs. Okay, where is this tables and graphs? Yeah, okay, I'll make section. So this tables and graph is a section, and this was let's say subsection tables, and then I will make the new subsection called graphs. Yes. After this at the end, now my new section start 2.2 graphs. Okay. So for these graphs, you should again you have to include a package. The package is there are two packages. I will write in this verbatim. So we have to use two packages, namely slash. I'll directly write the package. First is PGF plots, and next is TIGZ pictures. Okay, so I'll import these two packages there. Yeah, so these are this is the package, PGF plots and TIGZ. So this is something else. PGF plot set compact equals to 1.1. It's something weird, but I'll tell you later why or how. Why should I use this? Yeah, this is a compiler need, something I can say. Whenever you use some TIGZ pictures, there is some internal error the overleaf will make, and to resolve that error, the overleaf suggests to use PGF plot set something, the compact equals to 1.18. Okay, so no harm to use. I'll just go and directly uncomment this here, this, done. Okay, so now we'll make some plots. Yeah, by the way, I can again make some sections called subsection, and here I'll do 2D plots. Why it came as 2? Okay, 2D plots, right? Okay, 2 should be in number, let's say. Yeah, 2, I don't know, 2D plots. Yeah, looks fancy. Okay, so the syntax here is I should be starting with begin TIGZ picture picture. Okay, Tixi picture and end Tixi picture. So this is an environment for a Tixi picture. And then you want an axis, so like begin axis, end axis, so it will give you some sort of axis. And then you can add plot. Basically now in the squiggly bracket, so you mention whatever graph you want. For example, I want x squared. And here in the Tixi picture, you have to add semicolon at the end. Otherwise, the compiler will give you an error. Right, so here you have a beautiful graph of x squared. Okay. Now there are a couple of things unusual. For example, this is not the layout we are used to for the graphs. We want kind of middle axis, right? X0, X and Y. Yeah. So let's make some changes. So whenever you want to make changes into axis, go to the begin axis tab and then click the square brackets. The square brackets are always the optional cases. If you don't give any commands through square brackets, the overleaf will take the default commands and it will print something. It won't give you an error. But if you want to specify certain commands, you should use in square brackets. Okay, so what should I want? I want axis lines equals to middle. So these are some syntax that you have to remember. So yeah, from this, so what it does is now the axis lines are in the middle. So again, now if you can also mention from where x ranges, from where y ranges. I can write x min equal to, let's say, -5, x max equals to +5. Then I can write y min equals to, again, let's say, okay, y can be 0, no, because x squared only, so the graph will be upwards only. But still, I'll give -1. Then y max equals to, if my x is 5, then I should go to 25. Let's say 26 I'll go. Then what else you can do? Okay, so this from -5 to 5 is my boundaries. I mean the axis. You can basically also specify domain. The axis will be from -5 to 5, but what will be the domain of the function? You can also specify that. So I can say domain equals to let's say -2 till -1 till 4. There's some problem. No problem. Yeah. So now you can see it gave me a graph from -1 till 4, right? So this is good that if it is good if we specify the domains inside of functions, inside plots, not inside the axis, because sometimes you want some function in this range and another function in another range inside the same Tixi picture. So let's reserve this domain thing for the add plot commands. Yeah. So what else you can do? I want the labels of x-axis according to my preference. For example, I want 0, 1, 2, 3, 4, something like this. So I want xtick is the command. Xtick is the command. Then you can start, let's say, minus. Okay, it starts from -5, right? I have to do so many. So let's start x from 0. So x min equals to 0 to 5. Okay. And then the ticks will start from 0, 1, 2, 3, 4, 5. So now it will show from 1 to 5. Okay. And then, yeah, okay, this is enough. Let's make another graph, add plot, some other function, let's say x -1 minus x squared, something like this, semicolon. Okay, so I mean this won't be shown because the y is limited only till -1. So I should increase the y-axis, let's say from -5 to 25, not just -5, let's say -25. Yeah, also I should okay, let's remove this x tick because I have to put so many things there then. And let's say x min, I'll put again -5. Okay, yeah, now this is a nice graph. It looks somewhat problematic, right? Because you can think of it is y equal to x square and y equal to minus x square only, but there is a gap. If you took less points, then you will observe. Let's say if I take just -1, -2, 2, and the y also to be I don't know. Let's say 5, 5. Then yeah, here you get a clear picture. This is y equals to x squared. This is y equal to 1 minus x squared. Okay. Next, what else we can do in add plot command? In add plot, also you can put this square brackets, and now you can basically color individually for them. I'll write color equals to, let's say I don't want, now yeah, as soon as I use the square brackets, everything that was default is gone, right? Now you can see y equal to x square is just a plain black curve. Even it is not curve, if you observe it carefully, it is just kind of connecting lines. So now I have to specify everything. So color equals to, let's say, yellow, and then yeah, so color equals to, let's say, yellow, and then I'll do mark equals to asterisk, so that it will give the small stars. Now I can mention how many sample points I should take. For example, if I take, let's say, only 4 sample points, right? Let's say what happens now. You see, by only 4 sample point, it created a problem, right? Because it only took 4 sample points and made a curve, right? That won't give you a smooth curve. So instead of 4, let's make 10. Yeah, still not enough, right? So how about 50? So whenever you see there is some kind of rigidness in your graph, you just increase number of sample points. The only thing is it will take much compiling time, but it's not a big deal. Some kind of warning. Okay. Yeah, so these are the things you can do with the graph, with the curves. Okay, what else? Okay, let's make some other familiar graphs. Slash begin pixie picture slash begin axis, and again I will, yeah, first of all I'll just draw the graph. Slash add plot sine. So you can basically directly give command of sine because they have this function. And then I want to give degrees command because generally we assume it as radians, but here they take degree. Some problem. There is no need of this. Yeah, sine of degree of x, and then semicolon at the end. Yes. This is your sine graph, but completely weird. We don't want something like this. So we'll again make x min equals to, let's say I start from 0 and I go until, I want to go till 2 pi, but let's say I'll go till 2.5 times pi. Okay. And then Now you can notice that whenever you want to write pi, you have to use /pi, but inside a TXT picture, here something is like the compiler knows what pi means. It will give the value as 3.14, right? So it treats as a value, not something as an output here, okay, not as a text. So you don't have to write /pi. Now x min 0, x max 2.5 pi. Let's say y min equal to -1 and y max equals to +1. So because the graph will be from -1 to 1 anyways. Then I want axis lines equals to middle, so that I'll get this kind of axis. Yeah, what else? Yeah, so here, even if my graph is from 0 to 2.5 pi, you can see, the axes are 0 to 2.5 pi. You can see it closed something before only, right? The plot. So now these are the changes we should do inside plot. So here you now specify, first of all, let's say color equals to blue, and then now I want domain equals to, I say 0 till 2 times pi. I have to go from 0 to 2 pi. Right? Okay. So it went now from 0 to 2 pi, but it is not good, right? In the x-axis there are no pi's, like it's not good to see from 2, 4, 6. So now I will make x tick labels, so x tick equals to, now where you want to tick your x-axis. So I want 0, and then I want at pi by 2, then I want at pi, then I want at 3 times pi by 2, then I want at 2 times pi. So these are my x tick, right? But as you can see, these are not coming as pi, these are coming as values, because this TXT picture will treat them as value 3.14, as you can see. But I want to give them label now. So xtick labels now I can give. Xtick labels equal to, so 0 has 0, and now because here whatever I write as labels, it will be printed out as output. Hence here I should write slash wherever I use pi and all, because it is in the math environment now. So yeah, something problem. Yeah. So 0, then the next is pi. Okay, now it is pi by 2, so I have to write in fraction. First is pi, second is 2. Then the third command is just /pi, in the math environment, of course, /pi. Then the third one is again in math environment, /frac 3 times pi by 2. And the last one in the math environment, 2 pi. Right, so now if you see, yes, this is my curve, sin x, right? From the labels are also from pi by 2, pi, 3 pi by 2, 2 pi. Everything works fine. Right? So if you want some nicer curve, again, you can mention samples, some more samples. Let's say samples equals to, I don't know, 50. And what else you want? Yeah, this is fine. Okay, nothing else. Yeah. So if you want to kind of beautify your graph more, you can add something like x major grids, like x major grids equals to true, comma grid style equal to dashed. So what it will do is okay, let me see. Yeah, so it will just give me those dashed ticks, where there are ticks, it will give me those dashed straight lines. Okay, so now this one, let's add some other plot now. /add plot, color equals to red, and same domain equals to 0 to 2 times pi, and then samples equals to, I'll just make 30 samples, and the curve will be, let's say, cos of degree of x. So in the same graph, it gave me the sin x and also cos x curve, right? Now I want to label these two curves. I mean, label in the sense I want to display which one is sine, which one is cos. Okay. So for that, after this add plot, before the semicolon, you have to put node. Okay. So node will basically give me command. If I just write node and inside you have to write what node you want to give. F of x equals to, let's say, this is sin x. Right, this is the node. Let's see where it comes. So as you can see, by default, whenever you put node, it will come at the very end. At the end of the graph. For sin x, it came at the end. But it doesn't look good, right? It is on the axis. So now what you can do is you can position this node here. What are the commands is, first of all, write, comma, after this write command, you can write POS, which is positioning, let's say 0.8. So what happens? Yeah, now you can see what happened is, basically in this graph sin x, I have given a node called fx equals to sin x at the right position of the graph, right? Whenever you look at the graph, it is at the right of the graph, and it is at 80% when the graph is finished, right? So 0.8 basically means when the graph is 80% finished, there you have the node, right? So if I go and change this to, let's say, 0.3, so what will happen is it will come up at the 30% location of the graph. Yes, now you can see it came at the 30% location, right? So similarly, I can add node for this cosine graph also. I'll add node. I'll add node at right side, and then again position equals to, let's say I'll add this at 100% at the end. I want this node at the end. Some problem. Okay, I didn't mention what to, right? So here, let's say another function gx equals to cosine of x. Yeah, so this is my node. Okay, so now you see there is some problem because the graph has a specific length and height, right? But when I gave the node at 100%, so it is basically at the end of the graph, but there is no space for your graph right now there. So it kind of cuts off there, right? It cuts at the end, right? So if you want to switch it off, you just go in this axis, begin axis, and at the very first or anywhere you write clip clip equals to false, basically. Yes. So when you do clip equals to false, that cutting is not there, so you can go. I mean, at any point, at any end. So this doesn't look nice to me. Fx equal to sin x at 30% location, so I have to change. I will change it to, again, let's say 80%. Yep. So this is a nice graph of sine and cosine. Okay. Yeah, you have any doubt in this graph, or any question, suggestion, anything? So one more thing you can change is the positioning of those ticks. Okay, so right now those ticks, as natural, we write it came at the at the bottom of your x-axis, what you can do is where is x-tick labels? Yeah, x-tick labels are here. So after this, you can add another command as x-tick label positions, basically. X-tick label style equals to, here you have anchor equals to, let's say, so what is this anchor means? Where to which side of your text the graph will lie. So if I write, let's say, south west, okay, yes, so now you can see, so for each point, this is like east, west, north, south, right? So the southwest in this side, if you can see my video, I'm doing otherwise I'm just making hands in air. I'll just pin myself maybe. Yes, so pin for everyone. Yes. Okay. Huh. Yes. So what happens is at every point you consider this side as east, then west, then north and south. So southwest. So this is the position where the graph should lie. So northeast is the position where your location, the tick marks will be. So kind of an opposite you can think of where you want your tick marks to be. You put the anchor style to be the opposite of that exactly, right? So this is another styling you can do with the graph. So in between these two, I'll make some V space. 10 point. Okay, so one more type of 2D graph, let's say. It came down side. So now let's make some stacked graphs or stacked plots. Okay. So again, I want it to be centered, so I'll make begin center, end center. Again, the same environment, begin tick Z picture. Again, begin axis. But this time, I want a stacked graph, so it won't be like same XY. So in stack, you want the square brackets. So what I want is y bar equals to stacked. So I want to stack in y bar, and so I think that's all maybe. And then I'll add some plots. Slash add plot coordinates. So you give coordinates as follows. Let's say I give 0, comma, no, not 0, 1, comma 2, the first one. Then I'll give 2, comma 4, and then I'll give 3, comma 1 again. So this is my first plot, and then I'll again add another. First stack basically, coordinate, then 1, comma 1, 2, comma 4, 3, comma 2. So let's say what it will compile. Okay. Whenever you write here as coordinates, you are not supposed to put commas inside. So the stick picture is very restricted. You have to follow the strict syntaxes. It's not completely interactive. So again, some error. I think, let's see now. Yeah, okay. There is no equality symbol there in syntax, so just y bar stacked. Okay, so now you make a stack diagram with x-axis and y-axis. Basically, you can label the axis also. I didn't mention last time. How you can label is you just put x label equals to, let's say, x, and y label equals to y. These are labels for x and y axis. You can put anything. I mean, it depends. You generally this kind of graphs you plot regarding some quantity here and some quantity here. So you can put anything there, any text. Okay. Basically, A, B, C. And does words allowed? Let me see. Yeah, basically anything is allowed. Yeah. So this y axis I'll just write, and here I'll write x axis. Okay. Yeah. So same as the graphs also, here you can make the ticks on x-axis where you want. So let's say I want x tick equals 2. So my graph is only at 1, 2, and 3, so I want only those 1, 2, let's say 1, 2, 3. And if I want to label it by some other name, x tick labels equals to, I can write A, B, C. There should be exactly as many labels as there are x ticks. Is there any typo? X tick L A B L A B E. Okay. Yeah. Yes. So now you can see this is a very nice stacked diagram with x-axis, y-axis, and in the x-axis you have ticks at A, B, C. I don't know. It will represent something. Okay. And then yeah. So now in this kind of stacked labels, you want to specify what the blue thing means, what the red things means, and all, right? So for that, you have to add legend entry. This is the syntax for it. So you have to add legend entry bracket. Let's say I don't know, test1, something like this. Then no semicolon for it. And then if I add legend entry and test2. So test1 and test2 will be kind of a scores, and then you mention what lies on A, B, C, and you can make nice graphs. Yeah, I hope you understand the use of this stack diagrams. This is a general setup for the text stack diagram. You can add even many more. I mean, columns, rows. I mean, anything. For example, if I want to add more coordinates, I'll just write here, let's say 4, 3. So basically I have to make changes to everything. Here I have to make 4, label as, let's say, D. Even here I should make what it stands, 4, 1. Yes. Some problem. There is no comma. I always write comma. Right, so a nice stack diagram. Okay, this is all about 2D plots. Now let's dive into 3D plots. I think there was a subsection, right, for 2D? Yeah. So I'll make /subsection 3D plots. 3D plots. Okay. So any questions or comments? Something for 2D plots? I hope it was clear, right? So you can basically go to the TICS manual you can find it in overleaf reference guides, and interested um, students can go and search for different kinds of commands, different kind of functions you can graph, and you can make specifications in your graphs. There's a huge library there. So now let's go to 3D plots. So even here, the basic template is same. You have to start with begin TXZ picture, end TXZ picture, right? Again, begin axis and end axis. The only difference here is when you plot, you should write add plot 3. That will specify it's a 3D plot. Then you add some function, let's say 1 minus x squared plus y squared, like this, then semicolon. So let it compile. Okay, produced, okay. So why did it produce blue? I don't understand. Did I mention anywhere color blue? 3. Color. Basically, you can change basically whatever you want. Okay, maybe that's a default one. So now let's use the square brackets to kind of make it look good. But if you, let's say, don't write anything in the square bracket, then basically there are no commands he has for making it look good. Then you have such a graph. Okay, nobody would want to look at such a graph. So what I'll do is I'll copy, paste again with some nice specifications. Yeah. So what I'll do is now I'll write, let's say I want mesh, or let's say surf. What does surf do? If I write surf, surf means basically it creates a kind of a surface, yeah, a surface. So now you can see now it created a beautiful surface here. You can mention any function, two-dimensional function inside the squiggly bracket, and it will draw the surface accordingly. You can, similar to before, manage the axis however you want. You can also manage the viewing angles in this picture. I mean, because it's a 3D picture, you can view it from different angles, right? So there are syntaxes by which you can manage the viewing angle. So yeah, then what else you can do? Again, if you reduce samples, let's say I'll reduce 10 samples only, then the graph will not be smooth. It will give you kind of rectangles. This is the interpolation thing. I mean, in two-dimensional, in 2D plots, when you interpolate something, you kind of interpolate with lines, right? But when you go in 3D, whenever you interpolate something, you interpolate in terms of rectangles, right, in the surface. So basically, this is the mechanism. If you want more smooth graph, you include more sample points, for example, 30 or 40. Depends on how strong your computer is. Yeah, this is one type. Yeah, something else. Let's say I want mesh. So I don't want this surface, I want mesh with samples equals to 30. Right. So did not created a whole surface, but it created kind of a meshy uh, surface. Okay, what is the error? There's typo, samples. Okay, so these are two. One more type I think we have in this is some interpolaar, I guess. You add surf and then you kind of shade it with the shader equals to inter p, which means the interpolation. So now it will give you a very kind of a sleek surface. Where is this? Oh, it did not. Inter p. Is there any problem? Oh yeah, it now compiled. See, there are differences in all these three graphs, right? Okay. So this is about 3D plots. You can similarly plot different kinds of plots. Yes. So any doubts you have? If not, we'll now start a new, I don't know, section or subsection. Now I want to just create some graphics. I don't want these tables and graph. I want in between without axis. I want to create some, figures or something, some sphere if I want in my graph, or some rectangle I want. Then how can I create? Or I want to create a kind of a diagram. I want to create a tree diagram, let's say. So then again I'll use the TXZ environment. Yeah. So what I'll do is, let's say I'll draw. So draw is a command here basically. So I want to draw a circle centered at 0, 0 with radius, let's say 1. So I'll mention coordinate first, 0, 0. Then it is very simple. You just mention what do you want to draw, circle, and then inside you mention the parameter, let's say 1 centimeter. And you end it with semicolon. So now inside this TXZ picture, you can see it created a kind of a coordinate system which is invisible to us. We don't know like where it starts, but the 0, 0 position that you mentioned, that is from there you started a whole coordinate system. For example, now if I mention draw, let's say 0, 1 and circle of I don't know, 0.5 centimeter. So now let's see what happens. What happened? Okay. So it will take some time. So now from 0, 0 it created the whole coordinate system now in the whole TXZ picture bracket. Hence it went one distance up, 0, 1, and then it created a circle there. Right? You can create draw ellipse. Okay, I should mention first the point. Let's say 0, 0. I want to draw ellipse. Now for ellipse you have to give two parameters. Let's say one is 1 centimeter along x and 0.5 centimeter along y. Something like this. Okay, so it gives you sphere kind of a structure, right? Like whole circle and then sphere kind of structure. Okay, I'll remove this circle at the top. It's just annoying. And I will make everything come in center. It is taking some time. So one thing is, as a coder, you see these big graphs and all, there are huge components, right? It will take time to compile. So if they are there in the main text and you recompile the draft again and again, so it will take that much amount of time again and again to produce the same graph. So what you can do is you can make a different file. Let's say a new file, and I'll name it as TXZ images. And there I'll just make these graphs. Yeah, the whole thing. I'll cut, paste it there, and in the main text I should at least give some reference to that file, right? So I'll use /include this tximages.tex. Now if I recompile, let's see what happens. Yes. So I got my all the files. Now they are once compiled. I don't have to compile them all the time again and again. Okay. So now we'll go to graphics. Yeah. So this board, by the way, you can also do the, beautifying thing here also. Again, in draw you can make, let's say, very thick, and also you can, let's say, color it blue. So that will give the borders as very thick and blue colored. And let's say here I'll make again very thick. You can make thick, thin, small. There are plenty of commands. You can go and search for it. Then I'll do red. Right? Yeah, so then look good. Maybe I'll write it dashed. That means now it will show me a dashed circle. Okay, ellipse. I think it will look good if I reduce some size here, 0.3 centimeter, let's say. So like the y-axis is reduced. Now it is looking a circle, right? Sphere. Okay, what else I can do? See, a very good thing here is now instead of draw, you can use field draw. Okay, so field draw is another feature. I'll say red. So red will be the color, and where I should draw it. So the position 0, 0 at the right, you have 1, 0. So let's make it at 1.2, 0. And what I want here is a circle of radius very much less, let's say 5 mm. So what it will do, let's say. Okay, this is much big, not small. So let's say 1 mm. Still. Yeah, semicolon is not there. Okay, this is good, but even 1 is big. Let's say 0.5 mm. And not red, I'll use red, but with some percentage. Let's say red, just 40%, not the full. How about some black, red black combination? Let's see how it will look. So why I made the small circle there is I want to treat it as a bullet, and now I will write a node there. Okay, so node in square bracket, I will make the color of node. Color, how should write it? Let's say blue, but not complete. Let's say blue 40%, and then white 40%. What I want to write it there is sphere. Okay, let's see what comes as an output. Okay, so you see the text sphere came there, but not at the nice location, right? So for that reason, we have the anchor commands. So next is anchor. Anchor equals to, so I want the graph should be at the west of my label. So I write anchor equals to west and then sphere. It takes some time to compile. Yes, perfect. So this is what I want. So now this node is attached. Okay. Now this node is attached to uh, this graph. So if I just change the point, let's say from 1 point, I go for one, I go, let's say -1, 0 down. So do I have to change again the sphere and all? Nothing. So the node, that small sphere is attached to that point now. Wherever I move the point, the text will move. I'll move, let's say 2, 1. So it will go. Oh no, it's not good. Okay, so not a good, not a good location, but fine. So this is how you can attach nodes at any point. So yeah, okay. Okay, what else you can do now with the sticksy picture? Um, so let's say I want to draw some tree diagram, right? So let's see, begin sticksy picture slash big. Okay. In tree diagram, you don't need any axis or something, right? You just need nodes. So you write node. Okay, not this. Node. So the first is root. Let's say I'll call, and then maybe I want this to be very thick. The linings, not very thick, just very thick. And then I want to show like it will grow up or it will grow down, right? So grow. Let's say I want it up. Grow equals to up. And yeah, let's close it. And then I'll make child, then node, node in bracket left, let's say. So like from, okay, I'll just compile this and let's say what will come up. I'll end with a colon. Yeah, so you can see that because there is only one node right now. So from root, it went up and showed left, right? So what I will do is before the semicolon, I'll again make one more node child with the node as right. Now inside this node, I will make another. Sorry. Inside this node, I'll make another child node. So I'll shift it. Child in bracket node left. Then child in bracket another node right. Right, perfect. So let's see what it will show. Okay, some problem. There are so many brackets here, so I might have messed up in some bracket. So what is the problem? Oh, maybe I cannot give two node names at a time, I suppose. Okay, so I don't think it should be a problem. Okay, it's giving some kind of a red symbol here, but not an error, so I'm ignoring it for the moment. I don't know why it is showing this left and right. Okay, so from root there are two nodes, one left, right, not in a good direction. So basically, because it's in upward direction, that's why it's a confusion, right? Because it generally follows the downward direction, left and right, as a viewer point of view. So also what I can do is I can give arrows here. So with this symbol, right? So the same thing I can do downwards. First thing is, let's say what it will do. Right. So now see, because the standard notion of the tree diagram in the leaf is in the downward direction. When you make it upward, you have to give some different command, which is after grow you have to put one asterisk. It will tell the compiler, okay, change the orientation. So now it is proper left right, then left right. Okay, and same thing you can do for downwards again. I'll just copy the same thing. I'll put it back and not grow up. I'll do grow down. Right. So root, left, right, left, right. Perfect. Yeah. So this is these are the tree diagrams you can plot. You can plot rectangles. Basically, you can plot lines. Begin, or I mean, I don't need begin also. I just write slash tigz slash draw. Then I'll specify some point. Okay. Yeah. In some okay. Even this is fine. Draw. I'll just specify some point 0 0. And then when I wrote this means it will give me a line from 0 0 till 2 comma 2, and then again it will give me line from 2 2 to, let's say, 3 comma 1. So something like this. Yeah, so something weird. Without access, it looks weird. But you need some kind. So you need this kind of commands to organize arrows and all those things in your table contents. Okay. So yeah, these are all basics of tigz. How much you can draw, plot, and arrange tables. Yeah. So if you have any doubts now, you can ask. I will go to. Yes, I'll stop presenting. Yes. Yes, today's contents are over. In some sense, today's day is over. So if you have any questions, you can ask, or suggestions, or you want to repeat something or include something for tomorrow, you can also say that. I'll try to cover it in tomorrow. So basically, tomorrow it will be the LaTeX sessions will only be in the morning. If I can finish the Beamer and thesis document. Thank you, Krishna. So if I can finish the thesis and the Beamer doc type of document in 2 hours, then only in the morning I will take the LaTeX. In the afternoon, I'll arrange the guidance session as Sir asked. I'll try to arrange some friends of mine who are doing nice in their jobs, and also some PhD scholar from IISc Bangalore, myself. Yeah, just a minute. Yeah. Yeah, that will be the afternoon session, and the morning session will be the LaTeX. I hope this is recording. Yeah. There are so many. I have the worst experiences in such situations where the whole session I took, and then when I see the recording is not going on, so it's a nightmare. Okay then. So if there are no doubts, so let's meet tomorrow at same time, 10 o'clock, and the same link again. Thank you for participating.